So in part D, we need to find the total distance traveled by the particle over the interval 1 to 4 seconds. So what we need to make sure here is that our function has a shape that is not always positive or not always negative, which means that our velocity function has this shape from 1 to 4, so it goes down and then it comes back up. It is approximately at 4. So what we see here is that if we would integrate this, integrals are always signed areas, which means that an integral can be positive or negative, which means that if we find the integral of this and we add the integral of this, they will not add, the integral will find the difference of these two areas, as this here would be considered a negative area, so it would be this area minus this second area. But however, we need the total distance traveled. For the total distance traveled, we just need the area. We don't care about the sign. So what we can do is take the absolute value of our velocity function. That will make the whole thing positive. So that will make it like this. So we will have the same area, but this part will just be reflected on the t-axis, and therefore it will be positive. And if we plug this into our calculator with the absolute value sign, very important, then we will get that it is 0.9581. Therefore, this is the total distance traveled through this interval. We could have also done this in a more complicated way and in a longer way. We could have split this interval up into 3 sections and find the area of each of these three sections one by one and add them up manually. However, for that, we first need to find the x-intercepts and then find the integrals one by one and then add them up. I think this is a bit quicker.